Good day, good morning, good evening. Welcome to another edition. In this session, we'll be looking at Algebra, an introduction to first year university mathematics. The topic of interest today will be polynomials, and polynomials will be splitted into the following subtopics. We'll be looking at polynomials defined, long division, factorizing polynomials, completing the square, and the remainder theorem. So let us start with the first topic, which is polynomials defined, where we'll be looking at the definition of a polynomial. So our point of departure will be looking at the general form of a polynomial. The general form of a polynomial will be as follows. If we are given a function, let's consider using a of x. It will be equal to a0 plus a1 multiplied by x plus a2 multiplied by x squared plus a3 multiplied by x cubed plus many terms that will follow until we reach the last term, which will be an x to the n. This general form of a polynomial can be expressed using the sigma notation. Remember, the sigma notation, all what it does is it allows us to write the sum of a certain function in a way which is compact. So our a of x, if you can look carefully, if we want to use the sigma notation, we can write it as follows. It can be ar x to the power of r, because if you look carefully, whatever number which is sitting here is always matching up with the exponent. So that is why we have an r and an r there. But if you look carefully, we are starting from 0. So that's why our r will start from 0 and it will end at n, because as you can see, the last exponent is n and the last subscript is n. So this is how we can express our polynomial in sigma form. So we have a couple of terms which we need to define as we are looking at our polynomial above. So a0 is what we call the constant term of the polynomial. And then x is, in our polynomial, the variable. Specifically, it is the independent variable. And what we also have is, if you look at the other terms, what we will always have is AR. So our AR is called the coefficient of x to the power of r, as you can see here. Another important part which we need to make sure which we define is the degree of a polynomial. By definition, the degree of a polynomial is the highest power found in that polynomial. Just to use an example to understand this idea of a degree, let's quickly have a look at the degree of, as an example, x squared plus 2x plus 2. So if you look carefully, there is no confusion that this is a polynomial because it takes the form of, or the general form of, a polynomial which is written above. But remember, for the degree, we said it is the highest power which we see in that polynomial. And when you look carefully, the highest power which we see here is 2. So this means the degree of that polynomial there will be 2. If you look at another example quickly, if you're looking at the degree of 3x to the power of 4 plus, let's say, 7x squared plus 9, if we look carefully, we'll ask ourselves, what is the highest power which we can see for this on this polynomial? And if you look carefully, we are getting a 4. So that is how we get the degree of a polynomial. So you look at the highest power which you find there, and that becomes your degree. So if you look carefully, if we are saying we are looking for the degree of 3x plus 1, we need to look carefully here and say, what is the highest power of x? So if you look carefully, the highest power would be 1, which you do not see here. So it means the degree of a linear expression is 1. So make sure that you are comfortable with the idea of degrees. Essentially, the degree is the highest power which we see on whatever exponent or whatever polynomial which we are working with. So let's go to the next page and think of what happens when we have two polynomials which we are adding. How do we find the degree? So let's consider two polynomials. So let's consider a of x and b of x to be polynomials. If these are polynomials, then there's a couple of things which we need to be aware of. So if we take the degree, or if we are looking for the degree of, we add the two functions, a of x plus b of x. If you think carefully, the degree will depend, or it will be, as we always say, the power or the highest power which we see on the combination of the two, what you call expressions. So the degree will just be the maximum of the two degrees. So it will be the maximum of the degree of A, or you will take the maximum of the two. So you'll essentially be looking at the degree of A or the degree of B. So which one between the two is the bigger one? And that will give us the degree of the polynomial, which is a of x plus b of x. And if you go to number 2 and you subtract two polynomials, say you have the degree of u minus a of x and b of x, our answer will be the maximum, or will be the maximum or the bigger degree of either a of, or of either the polynomial a or b. So it will be the max of the degree of a, then the degree of b. So essentially you'll choose the bigger degree of the two polynomials to be able to get the degree of our a of x minus our b of x. And then 3, if we are taking, or if we are looking for the degree of our a of x multiplied by b of x, the degree of this expression will simply be equal to the degree of a, or the function a of x, plus the degree of the function b of x. Like that. That is what we are going to be getting. And then if we take any of these functions and multiply them by a constant does not change the degree. So if we are looking for the degree of c multiplied by a of x, remember c does not affect the x's. So the degree will always just be the degree of whatever the polynomial is, which is a of x. Now with this covered, let us go and have a look at some examples which are going to help us to understand and quickly apply these laws which I'm going to, or the laws which are above here. So let's name these laws degree laws. So let's quickly have a look at an example. And I'll just call it example 1. And in this example, we are given that our a of x is equal to 3 minus 4x plus 7x squared plus 5x cubed. And we are also given that our b of x is equal to 2 plus x minus 3x squared plus 2x cubed, then plus x to the power of 4. So what we want to go and test is, let's go and test law 1. So essentially, law 1 says that whenever we are looking at the degree of the product of two polynomials, a of x and b of x, the answer will just be Oh, no. Law 1 has the addition. So if we are finding the sum of two polynomials like this, then the degree of the answer will just be the max of the degrees of the two. So it will be the max of the degree of the function a and the function b of x, like this. So let's go ahead and find our a of x plus b of x. So if you look at what is going to happen is I'm going to copy a of x as it is, put it there, and then we are going to add it with our b of x. I'm going to copy that as it is also and put it up here. So we can now find the summation of these two functions. So our a of x, I'll just quickly add like terms, plus b of x. If you look carefully, we have the constant terms here, which is a 2 and a 3. That will give us a 5. And if you look carefully, we have these like terms, an x and a minus 4x. That will give us a minus 3x. We have another one, which is minus 3x squared and a 7x squared. And that will give us 4x squared. So that will be plus 4x squared. And then we have another combination of like terms, 2x cubed and 5x cubed. That will end up giving us 7x cubed. And then we have the last term, which is standing by itself, which is x to the power of 4. So if you look carefully now that you take the degree of the sum of the two functions, a of x plus b of x, it is just the same as taking the degree of whatever which we have found. And remember, when we are looking for the degree, we always take the highest power which we see on that polynomial. So we'll be taking the degree of this expression. And if you observe carefully, you will see that the degree of this expression 4 is the highest power. So the degree of a of x plus b of x is simply equal to 4. The law, because we know the law, would have taken a slightly different approach. So this is the left-hand side of our law, or law 1. This is our left-hand side of law 1, because I called what we have above there the degree laws. So if you look at the right-hand side, the right-hand side says that take the maximum of the degree of A and the degree of B. That is what we should do. So let's go ahead and have a look at the degree of A. So if you have a look at the degree of A of x, which is just the degree of, let's quickly copy our A of x there. So that is our A of x. So if we find its degree, you will see that the degree of A of x will simply be equal to 3, because 3 is the highest number or the highest exponent on this polynomial. And then we go and look at the degree of b of x, which will simply be the degree of the polynomial. So let's go and take the polynomial of b, which is that one. And if you ever look here, we are looking for the degree. And what is the degree? It is the highest power which we see. And if you look carefully, the highest power is a 4. So it means the degree is 4. And remember that the law says that you just take the max of the two. So what is the maximum of the two degrees? What is the maximum of the degree of A and the degree of B? So if you look carefully, you will see that the maximum of the two, or the bigger number of 3 and 4, will always be 4. So that is why we end up getting the same answer, that the degree of our a of x plus b of x equals 4. And that is what we found when we were doing it the long way. So make sure that you are able to deal with the work this way. If you go and do for a of x minus b of x, you will get the same answer. So if you look carefully, if you do a of x minus b of x, you will get the same answer. So let's quickly do that. So we'll quickly work this out as we did last time. So we have our a of x minus b of x. So the constant terms, 3 minus a2, what we get is simply 1, and then we go to the other like terms, minus 4x minus x, which will give us minus 5x. Then we go to the next set of terms, which are alike. We have 7x squared minus minus 3x squared. If you think carefully, minus minus will be a plus, so that will be plus 10x squared. Then let's go to the next set. What we have is 5x cubed minus 2x cubed, and that will give us 3x cubed. And then we have no term here which represents x to the power of 4, which means all what you have is 0x to the power of 4. When you subtract, you just get negative x to the power of 4. And if you look carefully, you can now have a look at the degree of a of x minus b of x, which is just the degree of what we just found above. Let's quickly copy that and give out the degree. So if you look carefully, this is still consistent with the formula which we saw on law number 2. So the degree of this polynomial, will ask ourselves, what is the highest exponent or the power here which we see? So if you look carefully, it is a 4, which is the highest power here. So this means that the degree of a of x minus b of x will just be equal to 4. So the degree, let's leave it at that, of a of x minus b of x is equal to 4. And this aligns with the law which we put up there, which you could have used, that even when you have the degree of a of x, if you're looking for the degree of a of x minus b of x, all what you could do is just take the maximum of the degrees of the two polynomials. So the one for a of x is 3, the other one is 4 for b of x, and the biggest number between 3 and 4 is 4. So that would still work out. So you can go and do number 3, where you quickly multiply the two and you see what you are going to get. So this would be expressing law 2. Let's quickly have a look at law 3, and then we move on from these. So law 4, you can go and try yourself. So if we look at law 3, all what law 3 says is that if we are looking for the degree of the product of the two functions, so meaning if we're looking for the degree of the two functions multiplying one another, a of x multiplied by b of x, all what we need to do is you just find the degree of our a of x and then add it with the degree which we find for b of x. That is what our law 3 is saying. So we already know the degree for a of x. I've shown you several times that the degree of a of x, you will just look at for the highest power, which when you look carefully, you'll see that it's a 3. And the degree for b of x, if you look carefully, it is a 4. So that means the degree which we get when we multiply the two, a of x multiplied by b of x, it will end up being our degree of a plus our degree of b. So essentially 3 plus 4, which will give us a 7. So when you multiply these two functions, it means the highest power of x, which we will see, will be a 7. Okay, so this concludes what we should be looking at as far as these 4 laws are concerned. This brings us to the end of the first section, which is polynomials defined. Now let's have a look at the second part of our session, which is focused on long division. So we have had a look at the degrees of polynomials and how do we find the degree of the sum of two polynomials, the difference of two polynomials, the product of two polynomials, and what I left for you to figure out for homework is the degree of a polynomial multiplied by a constant. So now let's dive and have a look at long division. So when can we divide two polynomials? That is the question which we can or we should ask ourselves. And the answer to this question is very easy. When can we divide two polynomials using long division? This will depend on the degrees of the two polynomials which we are dividing. So we can divide using long division a of x and b of x if the degree of a of x is bigger than the degree of b of x. Let me repeat that. We can divide a of x by b of x when the degree of a of x is bigger than the degree of b of x. So let's quickly make a note of that and I'll quickly elaborate on exactly what that means. Okay, so I had forgotten to include the equal sign. But essentially we can divide a of x by b of x when the degree of a of x is greater or equal to b of x. Let me show you an example. So what this means is, as an example, if our a of x is equal to, let's say, x squared plus 1, and our b of x is equal to x cubed plus 2x plus 1 is an example. If you look carefully, the degree of a of x here will simply be 2, but the degree of b of x will be 3. So using long division, I cannot divide a of x divided by b of x. I can't use long division to sort this out. And the reason why I can't do so is because the degree of a of x is not greater or equal to the degree of b of x. So essentially, for us to use long division, the degree of the numerator must be equal or bigger than the degree of the denominator. Let's make a note of that. Okay, so there's our note. For us to use long division, we require the degree of the numerator to be equal or greater than the degree of the denominator. So that is what we require in order for us to proceed and use long division. And obviously, all of you should now know that the numerator is what we have at the top, and what we have at the bottom there is our denominator. In order for us to understand long division, let's go and have a look at an example where we do long division and see how we end up getting to the answer. So this example, I'll call it example 2 because previously I worked on an example. I called it example 1. So this will be example 2. So what we are required to do is to find a divided by b. So we are required to find a of x divided by b of x. And we are given our a of x as follows. Our a of x is 2x to the power of 4 plus x cubed minus x squared plus 5. And our b of x is given as x squared plus 4x minus 3. So we become happy because we can see that we are dividing a and b, and the degree of the numerator is greater than the degree of the denominator. So if you look at the degree of the numerator, which is a of x, it is simply the degree of 7, that's 14 at 2, that. Now let's take the 33 and multiply back. So if you take the 33 and multiply back what was the other side, you'll see that we'll have minus into, you'll have 33x squared, and then plus 33 multiplied by 4. That will be 132x, and then we are going to have 33 multiplied by 3, and that is going to be minus 99. And then let's quickly find the answer to this. So if you look carefully, these will cancel. So the minus 33, or the 33x squared and the minus 33x squared will cancel. And what we'll be left with here will be minus 21 minus 132. And the answer will be negative 153x. And if you look carefully, we'll have 5 minus 95, which is the same as minus 99, which is the same as 99, plus 5, which is going to be plus 104. So we can't further divide into that. So this here, because the power now is less than that, we can't do any division. So this here becomes our remainder. So it means that when we do the division of that, we get what is on top here. That becomes our answer, but we have a remainder. So essentially, if we can rewrite this carefully, it is going to be, when we are dividing our a of x with our b of x, our answer becomes that there, which is 2x squared minus 7x plus 33, and we have a remainder. So essentially how you would write that would be, we will have that plus, so our remainder is always coming here at the top, so it will be minus 153 x plus 104, all divided by what we had originally, which is x squared plus 4x minus 3, like that. So that is how our answer is presented. This is example 2. So let's quickly jump into example number 3, where we do some division there also. So this is our example number 3. So let's go ahead and deal with it. So we'll have 3x squared plus 2x plus 1, and we are dividing this, or this is dividing the 3x to the power 4 minus x cubed plus 2x squared plus x plus 1. Okay, so let's go ahead and do our division already. So we are going to take this 3x to the power 4 and divide by it there. So when you divide, you'll see that all what you will have is x squared. Then we take the x squared, you multiply the x squared with all of that expression. So you'll have minus, you'll have 3x to the 4 plus 2x to the 3 plus x squared, like that. So let's quickly do the subtraction there. So what you will see is that this term here will cancel with that term. Then the other one will be negative x cubed minus 2x cubed, which is going to be minus 3x cubed. Then you'll have 2x squared minus x squared, which is just going to be x squared. The other terms, they come down, x plus 1. Then we go again and do exactly the same thing. This is the highest power, or the term that has the highest power. So we take 3x cubed, we go and divide by it there. So 3x cubed, or negative 3x cubed divided by 3x squared, you will get negative x. Then you take the negative x now, we multiply by it all there. So we'll have a negative into, this will be negative 3x squared when we multiply there, minus 2x. So the x will make it a cubed, 2x squared, and then minus x like that. And then what we need to do is to just minus these two and get the answer. So if you look carefully, this and that will end up cancelling. Then what we'll have is x squared minus 2x squared, which is going to give us 3x squared. And then x minus x, that is just going to give us 2x. Then we drop the 1. Then we go and divide again, because we still can. The power here is still not less than the power there. So we divide 3x squared with 3x squared. And when you do that division, you will see that what you get is a 1. Then that 1, we need to take it and go and multiply all what is there. So we take that 1, we multiply all what is there. And if you look carefully, what you will get is minus open bracket, you will get 3x squared plus 2x plus 1. And when you subtract this, you will see that what you will get is all of these terms will cancel. That term will cancel with this one and this one, this one and this one. So what we get is 0. So which means 0 is our remainder. And when 0 is a remainder, it means this thing divided fully. So it means what we have here is our a of x divided by b of x gives us what is on top of this thing that looks like a square root here. So we'll have our a of x divided by b of x. It will be equal to what is there, which is x squared minus x plus 1. This is our example 3 of long division. I hope you are able to make sense of this. Let us go to another example. We'll call it example number 4. And we're still looking at long division. Okay, so there we go with our example number 4. We are given our a of x as x to the power of 4 plus 3x to the power of 3 plus x plus 1. And our b of x is given as x cubed plus 2x squared plus 2. So let's go ahead and do our a of x divided by b of x. And we know that this is just going to be b of x. And we'll put in our a of x inside here and do the work. Okay, so let's go ahead and do exactly that. So when we divide, our b of x will be here. So we have x cubed plus 2x squared plus 2. Then our a of x, we put it here. Okay, there's our example number 5. So let's go ahead and do our calculation. So remember, we are happy because we can see that the power of a or a of x is bigger than the power of b of x. So which means we can easily do our division. So let's go ahead and do our a of x divided by b of x. So remember, we will always put in our b of x here, and then our a of x will come there. So x to the power of 4 plus 1. So let's do our division. So it will be x to the power of 4 divided by this here, which is 2x squared So if you think carefully, when you divide those, what you will get is half of x squared, like that. Then we take this here, we multiply it with all what is there. So we'll always minus with all what is there. So when you multiply half of x squared with 2x squared, what you get is x to the power of 4 plus half of x squared, like that. So let's quickly do the subtraction of these. And when you subtract, you will come to a realization that that term and this term will end up cancelling. And what will be left will simply be 1 minus, let me write it as negative a half x squared plus 1. Okay, but when I look carefully, this power is still equal to that one, so it's not less, so I can still do some division. So if I do a half or negative half x squared divided by 2x squared, what I will get will be negative 1 over 4, like that. Then I can go ahead now and do the multiplication, like that. And if you think carefully, so we'll be left with 1 plus 1 over 4, which if you think carefully, 1 plus 1 over 4, that is the same as 4 over 4 plus 1 over 4, which will be 5 over 4. So that is what we have as our remainder. So we have 5 over 4, and that, or this here, is our remainder. So this means that our answer will be written as follows. So we'll have our a of x divided by our b of x equaling, if you look carefully, it will be the half of x squared minus 1 over 4, and then plus 5 divided by 4. Since this is the remainder, we will always divide by whatever the denominator was, which we're dividing by, 2x squared plus 1. So this is our answer for example number 5. So this brings us to the end of long division. I hope that you are able to make sense of what is going on and how we do this long division in general. Now, the next section of our session is factorizing polynomials. This you have done a couple of times from back in high school, others in college. So let's have a look at factorizing. So what I'm going to do is I'm going to use examples in order for us to understand how do we factorize. You've done this a couple of times. So let us dive into examples and see how we deal with this. The first example, I'm just going to call it example number 6, because where we left on the previous section was example number 5. So what we have is example number 6, and what we are required is to factorize the expression. And what we are given is x squared plus 5x plus 6. So this should ring bells from high school. So essentially, we are looking for two numbers whose product is 6, but the sum of the same two numbers, or when we sum them, we should get 5. So we're looking for two numbers, their product is 6, but their sum is 5. Okay. So how do I know that we are looking for two numbers? Because on the note I wrote that the product of the two numbers should be a 6, the sum should be a 5. How I know that we are looking for two numbers is because of the degree. The degree 2 tells us that we have two brackets, or essentially two factors, which when we multiply, we'll end up getting that. So if we find ourselves having an x cubed, it means I'm going to worry about having 3 brackets. So now let's go ahead. Two numbers, when you multiply them, you get a 6, but when you add them, you get a 5. That sounds like a positive 3 and a positive 2. So I put in my x, done. I'm done factorizing here. So this has been factorized. And we can smile. Easy. Right. So let's go to the next example where we need to factorize and see how we deal with that. And that will be example 7. Okay. So let's have a look at example 7. We are required to factorize x squared minus 5x plus 6. So essentially, I need to ask myself which two numbers, when I multiply, I will get 6. But when I add the same two numbers, I get negative 5. So if you think carefully, two numbers, when I multiply them, I need to get a positive 6. When I add them, I need to get a negative 5. That sounds like a negative 2 and a negative 3. When I add them, I get negative 5. When I multiply them, I get a positive 6. X. So just like that, we are done with this problem. Easy, easy, and easy. So let's go to example number 8. For example 8, the expression which we are required to factorize is x squared plus 2x minus 15. So I need to think carefully. I need two numbers. When I multiply them, I get negative 15. But when I add them, I get positive 2. So if you think carefully, that sounds like a 3. Somehow when I multiply, I can get a 15 with the 5. But I need a positive 2 when I add them. So it means it's the 5 which must be negative, which must be positive. So this is how we would factorize this expression. So negative 3 and negative 5 multiply to negative 15, but they add up to positive 2. Done with that, let us go to example number 9. For example number 9, we have x squared minus 2x minus 15. So if you think carefully of what is going on, we are looking for two numbers. When you multiply, you get negative 15. When you add them, you get negative 2. If you think carefully, those are negative 5 and positive 3. So essentially, when you multiply positive 3 with negative 5, you get minus 15. When you add them, you get negative 2, which is the middle term. So this is good as done. Okay, that was easy. However, what I need you to note is that at times you will find yourself needing to use the quadratic equation, because sometimes these factors will not be so obvious as they are. So let's quickly make a note. And the note is that whenever needed, use the quadratic formula. If you're struggling just finding the factors on top of your head, of which it will happen at times. Okay, so make sure that you do use the quadratic equation whenever necessary when you are struggling to find the factors. So with that said, now let's go and have a look at example 10. So in example 10, we are required to factorize. But what we are required to factorize is a very interesting. So we are required to factorize 4x squared minus 9. So if you have a look at this, you should be able to see when you spot it that actually what we have here is a difference of 2 squares. Why am I saying it's a difference of 2 squares? If you remember, when we have a squared minus b squared, these are 2 squares, but we're finding the difference. This will always be given by, or it will always be equal to a plus b, a minus b. So when you look at my expression there, 4x squared minus 9, this I can actually write as 2x all squared minus 3 all squared, and this just becomes a difference of 2 squares. Now if you look carefully, this will be 2x minus 3 and 2x plus 3, just like that. and this is what they would be expecting you to be able to deliver, and whoever is marking would be happy. Okay, so make sure that you know your difference of two squares. So this here is important. Now let's have a look at example 11, which I'm going to leave halfway for you to finish as your homework. Then I'm going to do 3 other examples and then we move on. So let's have a look at this one. So what we have is x to the power of 6 minus 3. So there's a couple of ways we can deal with this. I can attempt to make it a difference of 2 squares, and I'm going to leave it there. So this can be written as x to the 3. Then I put in the square outside. But because I want to put a square outside, it means I need to put a square root so that this, when it multiplies in, the powers end up becoming the same thing. And if you remember, the difference of 2 squares will always give you x cubed. It will be minus square root of 3. And then I'll have x cubed plus square root of 3. Like that. So this is a more simplified form. And you can go and factorize this even further. I'm just going to leave it as homework for you to work further on this problem. I'll go to example number 12. This one, take it and give it some thought and see if you can expand it until you have linear factors. Something times x plus something. Do not have x cubed. Okay, let's go to example number 12 on the next page. Okay, so here's our example number 12. So we're required to factorize x squared plus 4x minus 5. So I'm looking for 2 numbers. When I multiply them, I'll get negative 5. When I add them, I will get positive 4. So if you think carefully, what will multiply to 5 will only be a 1 and a 5. But I need the answers to add up to a positive 4, which means the 5 must be positive, the 1 must be negative. So this becomes my solution for this problem. Okay, this was easy. 2 numbers which should multiply to negative 5, but they should add up to positive 4. So let us go to example number 13. So for example 13, we are required to factorize 2x squared plus x minus 1. So this here is what makes us to take this problem slightly different. So I just can't say look for 2 numbers, when you multiply them you get minus 1, you add them, when you add them you get positive 1. That 2 there makes a difference. So it means that I'm going to have 2 brackets. One of the bracket will have 2x, one of them will have x. Then now I need to think of the last numbers. What is it which, when I multiply the 2 numbers, when I multiply together, I should get negative 1. So if you think carefully, that might be positive and negative 1. So I'll put in 1 and 1. But now I need to ask myself, where should I put a negative and where should I put a positive? And this will depend on the sign here. So since there's a positive here, the only way I can get a positive 2, which will minus a 1, is if I put a positive this side. So if I put a positive here and I put a minus here, you'll see that when we multiply, we'll have 2x like that, and then minus x, and that will end up giving us positive x there. So this means where we place the negative and the positive is the correct location where they should be. So this should make us to smile. Right, so let's go to another example. We'll call it example number 13. It will be example 14. So just like the others, we are required to factorize. And what we are required to factorize is negative x squared plus 2x plus 8. So if you look carefully, the negative there gives us a problem. It doesn't make our life to be easy. So we have 2 options. We can just pull out the negative and have x squared minus 2x minus 8, like that. Then we need to ask ourselves, which two numbers, when I multiply, I will get negative 8, and when I add them, I will get negative 2. So if you think carefully, those numbers, it sounds like we have a 4 and we have a 2. They multiply to 8, but we need a negative 2 when we add them. So this means the 4 must be negative, the 2 must be positive, like that. Okay, so that is the negative. The negative, we can take it and multiply one of the brackets and have maybe negative x minus 2, like that, and then have x minus 4. This still works out as a solution. So that solves the problem which we were presented with as example number 14. I hope this does make sense. We'll now be looking at the next section as outlined when we begin the session. So we are going to be looking at completing the square. So completing the square is one of those important topics which you need to know as you are starting off your journey in algebra or calculus at university level. So let's have a look at a quadratic. So mostly you'll be working with quadratic functions. So let's have a look at them. So I'll give you the standard form of a quadratic function. So the typical form which you will always find, it will be in the form of ax squared plus bx plus c. And the question which we want to ask ourselves is, how do we complete the square? And how we complete the square will be as follows. So I'll do it in a set of steps. So I'm going to say step 1. What you want to do when you are completing a square, if the coefficient of x squared is not 1, you want to factor that out. So I'll say factor out the coefficient of x squared if it is not equal to 1. That is what we want to do. So which means if we have ax squared plus bx plus c here, since I can see that the a is not equal to 1, I'll factor it out. So I'll have x squared plus, if you look carefully, b over a, x, and then plus c over a. That is the first step which you do. When it is equal to 1, it means you do not need to do this kind of step, but you always factor the coefficient of x squared if it is not equal to 1. Then what we go and do is we look at our step number 2. So in step number 2, what you want to do is you want to create a bracket. So what we have is a. Step number 2, essentially what we want to do is you want to halve the value of b, square it and subtract it. So if you look carefully, I'll have x plus the coefficient of x is what we want to halve. So if you look carefully, if we halve the coefficient of x, it will be b over 2a. Then you put in a square. Then you minus the coefficient of x, which you have halved, but you square it now. So 2a squared, like that. Then plus that c over a. Then you put in your square bracket. So essentially for step number 2, all what you want to do is you want to halve the coefficient of x and then subtract it when it has been squared inside the bracket. So that is what we did here. So essentially you want to halve the coefficient of x, which was that there, it was b over a. When we halve it, it becomes b over 2a. Then you subtract that halved coefficient squared. That is what we did here. Okay. And then if you look carefully, you can now add the terms. So you'll have the a into If you look carefully, you'll have x plus b over 2a all squared, and this will be minus b squared over 4a. And the plus c over a there, we can easily try and make a common denominator by multiplying by 4 and 4. So you'll have 4c divided by 4a. The reason why I'm trying to do this is just to combine those denominators. So if you look carefully, this will end up being x plus b over 2a all squared plus, if you look carefully, you'll have 4c minus b squared divided by 4a. Close the bracket. So we can now go ahead and rewrite this quickly on the next page. Our square has been completed. So this will be equal to, if you look carefully, when we multiply back, it will be a into x plus b divided by 2a, and this is all squared, and this will be plus, if you look carefully, 4c minus b squared. The a there will end up cancelling, so this will end up being like this, plus 4. And this is the standard form once we have completed the square of any function. So when we have completed the square of any function, we are expecting it to be in this form. So by definition, the general form of a quadratic function which you see after completing the square will always be in the form of f of x will be a into x plus or minus p and then plus q. So not forget the square. So this is how it will generally look after you are done completing your square. This will also be plus or minus. Let's just move that down. So this will be the general form which we have after completing the square. So remember the two steps. Factor out any coefficient if it is there and do this which we have done here. So let's go and have a look at an example and we will come to appreciate how we do this. And that example will be example number 15. So here's our example number 15. So what we are happy of, number one, is that the coefficient of x squared is 1. So meaning our life becomes a bit easier. So that means we can easily go ahead and do our work, because this makes us to be a bit happy because we have a step which we can just skip. So we have x squared plus 6x plus 5. So remember what I said is that you will have x plus, you always half the value of b. So half the coefficient of x. So half of 6 will give us 3. And then squared minus, remember we always minus half the coefficient of x, which is 3, all squared. Then plus the 5 there. So if you look carefully, we'll have x plus 3 all squared. This will be minus 9 plus 5. So if you look at the final answer, it will be x plus 3 all squared minus 5, minus 9 minus 5, that will end up being minus 4. And as you can see, this takes the form which we are always looking for, which is a is x plus or minus p all squared plus or minus q. Let us go ahead and have a look at example 16, where we still need to complete the square. Okay. So I quickly did example 16 here, where I was completing the square. So we're given x squared minus 10x plus 4. Lucky enough, the coefficient of x squared is 1. So all what we did was to go and half the coefficient of x, which was minus 10. We get minus 5, and we always subtract that coefficient which we halved. We always minus it squared and then plus whatever which was there. And we get negative 25 plus 4, which adds up to minus 21. And that looks as the standard form which we see on the right-hand side. Okay. So let's go to example 17, where I am still required to complete the square. So for example 17, as previously said, we are required to simplify by completing the square. And what we have is 5x squared minus 30x, or 3x. Let's quickly put in 30x, then minus 2. So when we look carefully here, we can see that, we have a coefficient there for x squared. And that coefficient there is definitely not 1. So what we need to do, as I previously said, we will need to go and factor out the 5. So when you factor out the 5, you will get 5 squared. Then when you divide the 30 by 5, so we'll say 5x divided by, or 30x divided by 5, then minus 2 divided by 5. If you look carefully, we'll have a 5 into, so we'll have x squared, 30 divided by 5, we'll get a 6. So we'll have 6x minus 2 over 5, like that. So essentially what we now need to do is to go and complete the square of what is left inside there. Okay, because what we now have here is we become happy because the coefficient of x squared is now 1. And once it becomes 1, we become very happy because it becomes easier to deal with completing the square. So we'll now have our 5 into, we'll open our bracket, we'll have x. Then we always divide the coefficient of x by 2, which will give us minus 3 all squared. And we subtract what we have there, which is minus 3 all squared. Then minus whatever which we originally had. So if you look carefully, what we are going to have is 5 into x minus 3 squared, and this will end up being minus 9 minus 2 over 5. So we should go ahead and try and simplify that there and collect it to a common denominator. So if you think carefully, minus 9 minus 5 over 2, or sorry, minus 2 over 5 will be, it will be negative 47 divided by 5. That is what we are going to have. And if you look carefully, the 5 is just going to multiply in. So the 5 will multiply there, but also it is going to go and multiply even that side. So if you look carefully, the final answer will simply be 5 into x minus 3 all squared minus 47. And this now looks like the standard form of a quadratic, which we usually see after completing the square. Because remember, the standard form usually looks as follows: a into x plus or minus p all squared plus or minus q. This is the standard form which we usually get after completing our square. And that is exactly what we have there. So this is how we complete our square. There's many problems which you can attempt to make sure that you understand this even more deeper. Okay, so we can now go ahead and do the last section of this lesson, which is the remainder theorem. So the remainder theorem is useful when we are trying to factorize polynomials which have a degree 2, 3, 4, and even higher. So with the remainder theorem, all what we are concerned about is if we are given a polynomial which we are trying to factorize, can we find a factor that when we take in the x value there, when we put it into the function, we get a 0. Then we'll use that factor to do long division and find other factors. So let's quickly write down the remainder theorem. So the remainder theorem states that when a of x is divided by x minus k, the remainder is a of k. So let's quickly have a look at an example so that we can display or try and understand what the remainder theorem is and how we use it. The example we'll be looking at will be example 13. My apologies, it will be example 18. And for this example, what we are required to do is to use the remainder theorem. We need to use the remainder theorem to factorize the following. That is what we are required to do. So the first expression which we have, which we need to factorize using the remainder theorem, is our a of x equals x cubed minus 7x plus 6. So with the remainder theorem, what we need to do is we need to establish at least one factor. That is what we need to do. So can we find at least one factor? That is the question which we should ask ourselves. So usually how this will work is we'll look for an x value, which when we put on our a of x, we get 0. So as an example, you can go there and say, let me try x is 0, which is obvious. It will not end up giving you 0. So you'll have 0 cubed minus 7 and then plus 6. And you look carefully, you will end up getting an answer, which is 6. And this means that the x minus 0 is not a factor. That is what it means. So this means x minus 0 is not a factor. So we only know it is a factor when once we plug in whatever x value, we get a 0. So let's try, for example, 2. If I put in a 2, I will have a 2 cubed minus 7 times 2 and then plus 6. So if you look carefully, this will be 8 minus our 14 and then plus 6. And if you look carefully, this will end up giving us 14 minus 14, which is 0. So once we get a 0, we become happy. We become happy because what that means is that our x minus 2 is a factor. That is what this means. So once we find one factor, we can now go and do long division after finding one factor. So that is what I would advise, that do long division after finding one factor. So let's go ahead and do long division for this problem so that we can factorize it. So what we have is we saw that x minus 2 is a factor. And this x minus 2 is dividing x cubed minus 7x plus 6. So this is why earlier we were learning long division, so that you can be able to easily, factorize expressions which appear complex. And this will be useful when you do partial fractions. So x cubed divided by x, you will see that what we will get will be x squared. Then we take our x squared, we multiply by it there. So we'll have minus, if you look carefully, we'll end up having minus x cubed, then minus 2x squared. Then if we do some subtraction here, you will see that this term and that term will cancel. And what I will have will be negative 7 x minus x minus 2x squared, which will just be 2x squared. And then minus 7x, then plus 6, like that. Then if you look carefully, I can still divide this 2x squared with that x there. So when I divide them, what I will get will be 2x. Then we take the 2x, we multiply that expression with it. So I'll have minus, open bracket, we'll have 2x squared minus 4x, like that. Then we take the difference. So if you look carefully, there's going to be terms that cancel, which is that one and that one. And we will have minus 7x plus 4x, which will be minus 3x. And if you look carefully, we'll take the 6 down. Okay. Then we can still go ahead and divide. So we have minus 3x divided by x. That means all what we'll have here will simply be minus 3. Then we take that minus 3, we multiply it down there. And if you look carefully at what we will have is we'll have negative 3x, then plus 6. And if you look carefully, this will become 0. So that means our remainder is 0. So this means that when we are looking at our factors, we already knew one of them, which is that one there. So it means our factors for that, our a of x can be expressed as I have x minus 2, remember. Then the other one, which is at the top now, is x squared plus 2x minus 3. So I can further split this apart and have our a of x equals x minus 2, open bracket, two numbers. When I multiply, I get negative 3. When I add them, I get positive 2. If you think carefully, that is x plus 3 and x minus 1. So that is my function factorized. The question was, use the remainder theorem to factorize the following. And that is what we ended up finding. I hope you are able to make sense of this and you understand. Let's have a look at one more example and then we can call this session to an end. Let's have a look at example 19. So let's have a look at example 19, which is x cubed plus 2x squared minus 5x plus 6. And this will be our a of x. So we need to try and factorize it. And remember, we're using the remainder theorem. So I'm going to try a couple of x values and see if these are going to work. So I'm going to go and try x of 1 as an example. So I want, when I put in an x value, to get 0 out of this. So I'll have cubed plus 2 into 1 squared minus 5 into 1 minus 6. So if you quickly have a look at this, it will be 3 minus 5, which will be minus 2 minus 6. This will be minus 8. So because we are not getting 0 here, not equal to 0, what we can tell is that x minus 1 is not a factor. Okay, so we can move on. I'm going to try, let's say, as an example, 2. So if we look carefully, we'll have 2 cubed plus 2 into 2 squared minus 5 into 2 minus 6. And if we quickly have a look at this, it will be 8 plus 8, which is, let me see, 16, and then minus 10. That will be 6. And then minus 6. That will give us 0. So let's quickly confirm if I'm on point. So this will be 8. This will be 8. This will be minus 10. This will be minus 6. And as you can see, this will be 16 minus 16, 0. So what this means is that x minus 2 is a factor. So I'm going to use it on our remainder theorem. So once we see a 0, we should be becoming happy. Because once we get a 0, it means our remainder theorem, we are just a minute away from using it. So this should make us to smile. Because we now have one factor which we are going to use to find the others. So we have what? X minus 2. And that is going to be dividing x cubed plus 2x squared minus 5x minus 6, like that. So let's go ahead and begin our process. So we'll have x cubed divided by x, which will give us x squared. Then the x squared will multiply down there to give us if you look carefully, when we open the bracket, you'll have x cubed minus 2x squared. So when we quickly subtract these, you will see that these terms will cancel, and what we will have is 2x squared minus 2x squared, which will give us 4x squared, and the other terms will come down as they are. Right. Then now we need to go and divide again. 4x squared dividing into x, if you think carefully, that will just give us 4x. Then we take that 4x, it multiplies down there. Then we'll have minus 4x squared minus 8x, like that. Let's go ahead and find the difference. So if you look carefully, there's terms that are going to cancel. This term and that term are going to subtract to 0. Then what we'll have is minus 5x minus 8x, which is going to be 3x minus 6. That is what we are going to have. So let's create some space here and try and wrap this up on this page. So we can go ahead and divide once again. So we need to take the 3x and divide it by x. And if you look carefully, the answer will simply be 3. Then we take that 3, we multiply by it there. Okay. And when we multiply by the 3 there, you will see that we'll have minus, it will be 3x minus 6. And finally, we get 0 and we stop once we get 0, because our answer has been completed essentially. So we can now go ahead and just write our answer. So our a of x can be written as, we have one of the factors x minus 2. Then the other portion is what is there at the top. So it is x squared plus 4x plus 3. And if you think carefully, this you can easily factorize. Two numbers multiply to 3, but they add up to 4. So you will see that this is as good as a 3 and a 1. So we have x minus 2, x plus 1, and x plus 3. This is what we are having as our answer. So let's have a look at the last example, which is going to be example 20, and then we conclude. Right, let's have a look at example 20. We are still using the remainder theorem to be able to factorize. But for example 20, what we have is x cubed minus 2x minus 4. And this will be our a of x. So what I'm going to try is I'm going to put a of 1, which you can easily see that it's not going to work. Minus 2 into 1 minus 4. If you look carefully, this will be 1 minus 2, which will be negative 1 minus 4, which will be minus 5. And as you can see, this is not equal to 0, which means that our x minus 1 is not a factor, because that 1 is not working. So it is not a factor. So we move on until we get an x value, which when we put in, we'll get a 0. So let me just guess a 2. So a of 2, you'll have 2 cubed minus 2 into 2 minus 4. 2 cubed is 8 minus 4 minus 4. And if you look carefully, this becomes 0. And this here makes us happy. We become very happy because this is now 0, which means that our x minus 2 is a factor. So therefore, x minus 2 is a factor. So we can now go ahead and do our long division so that we can find the other factors. So it means I'm going to do x minus 2. This will be divided, or x minus 2 will be dividing into x cubed minus 2x minus 4. So let's go ahead and do the work. X cubed divided by x, that will give us x squared. Then we take the x squared, you multiply by it there. So we always put a minus, open bracket. If you multiply, you'll have x cubed minus 2x squared, like that. So when we subtract these ones, you will see that the x cubed terms will cancel. So that term and that term will cancel, and what we will have will be 2x squared minus 2x minus 4. Okay, then let's go ahead and do this one now. So you have 2x squared divided by x. So that will give us 2x. So we'll take that 2x, multiply by it there. So we'll have minus. If you look carefully, we will have minus, it will be 2x squared. Let me see, minus 4x. If you look carefully, then let's take the difference. So when we take the difference, you will see that the two terms will cancel. So this term and that term will cancel. And then the other one will be minus minus, which will be positive. So we'll have 2x minus 4, like that. Then now what I need to do is to divide for the last time. So 2x divided by this 2 there. Let's think carefully. Minus 2, 2, and then minus 4. Okay, so when you divide there, you will see that what you have is a 2. Then when you multiply with the 2, you will see that you'll have 2x minus 4, and this will end up giving us a remainder of 0. So since we get a remainder of 0, it means that we can go ahead and express our final answer as follows. So our a of x will be x minus 2, and at the top there what we have is x squared plus 2x. Let me think carefully. This will be plus 2x plus 2x and then plus 2. So you can attempt to expand this further, but I will leave it here. I hope that you understood the work and you were able to grasp what we were doing and follow until the end. So please do not forget to like and share. Tell others about this video if it was useful to you. I hope that you did enjoy. So all topics which we were planning to cover are all done and dusted. Polynomials defined, long division, factorizing polynomials, completing the square, and the remainder theorem. Thank you and bye-bye.